In this video, we are going to talk about graphs of functions and their inverses. All right, so the key fact that you need to know about the graph of a function and its inverse is that those two graphs are symmetric about the line y equals x. Okay, so I've got three examples to show you, f, g, and h and their inverses, and we're going to graph those out and along with the line y equals x. And we're going to show that the graphs of those functions, of each of these functions, is symmetric about the line y equals x with the graph of its inverse. Okay, so let's take a look at it. So first example is f of x equals 2x plus 3, right? That's this blue graph right here. It's a line, right? And if I graph the inverse, and now you may say, hey, why did you write it like this on the inverse? Well, on Desmos, I can't use the f inverse notation, so I just had to call it something different than f, so I just called it f1. All right, so don't worry about that too much. This is the inverse. Okay, so when I graph out the inverse, its graph is also a line, right? And it's this orange line right here. And so you can see, right, the key fact, right, is that if I take a look at the graph of y equals x, which is the graph of this line, and I'm going to draw it in as a dotted line here, it's not, part of the graph of either of these functions. It's just kind of a guideline. So if you imagined, right, that I took and I printed out this graph, right, that I have, and then folded it along the lines y equals x, right, what would happen is that this orange graph, right, would line up exactly with the blue graph everywhere, right? Everywhere there's the blue graph, right, it will line up with its orange counterpart over here, okay? All right, and so that's what we're talking about, being symmetric with respect to this x-axis. All right, so that's example 1. Shut that off and take a look at example 2. Okay, so example 2, right, we have this function minus 2x squared plus 6, right, and so its graph kind of looks like this, and you might see this and go, hey, what is the deal with this thing right here? And so the thing is if I just do minus 2x squared plus 6, right, I get this upside down parabola that looks like this. And so this function is not a one-to-one function. It does not pass the horizontal line test, right? Any horizontal line down here is going to cut the graph in at most one spot. And so therefore, right, the function g of x equals minus 2x squared plus 6 does not have an inverse function, okay? So even though a function does not have an inverse everywhere, right, what you can do is chop down its domain a little bit. And so that is what this, that's what we're going to do here, right? The normal domain of minus 2x squared plus 6, it's a polynomial, right? So it's, normal domain is all real numbers, right? And so if we chop it down, right, and only restrict the domain to this half, right, over here, then just this part is a one-to-one function. And so therefore we can find an inverse function for this part here. All right, so that's what's going on with the x greater than or equal to 0. That is a trick that we use to get inverses for small parts of functions that are not one-to-one. We cut it down so to a part where it does pass the horizontal line test, and we can then find the inverse of it. And if you have to take pre-calculus, you'll see that in a couple of places in that class. Okay. All right. So then if I do the algebra, I will get. And again, don't worry too much about how I got this. It's that process that I showed you in the previous video, but we'll work some examples of how to do this, where we're actually finding these inverses. All right, and there you can see that's the graph, right, of the inverse. And again, right, the main fact about the graph of a function and its inverse is that they are symmetric, right, about this line y equals x right here. In other words, if I printed this out on a piece of paper and then carefully folded, right, the piece of paper along this dotted line y equals x, you could see that the orange graph, right, when I fold it, is going to line up perfectly with this part of the blue graph over here. This part of the orange graph, right, is going to line up exactly with this part over here. Okay. All right. And then the last example. All right, in the last example, I have this rational function, right? X plus 2 over 9x plus 7. It looks like this. Okay. And again, its inverse is this function here. And I will show you how to calculate that out for a rational function like this in a different video. So if I graph the orange function, right, you can see that's what it looks like. And again, once again, the point that we're trying to illustrate here is that if I take and print this out, right, the orange graph and the blue graph are symmetric, right, about this line y equals x. In other words, if I print this graph out on a piece of paper and fold it along this dotted line, right, then you'll see this part of the blue graph will line up where the orange graph, which is its inverse, right? This blue part would line up exactly here. Same thing down in the bottom part like that. So the graph of a function and its inverse, right, are symmetric with respect to this line y equals x.